Okay, welcome guys. This is the second lecture. I will just continue from where PJ stopped the other time. But most importantly, this is an advanced class. This is not secondary school. So most of our discussion, most of the classes, don't see it like training. If you notice how PJ break things down for you the other time, the training aspect of it is very small in terms of percentage. So it's kind of training, coaching, mentorship, and internship. Like it's more or less like you are working, but we just don't want to assume that everybody have the necessary knowledge. That's the reason we are taking you through the knowledge. Okay, if you have passed through some knowledge for a long period of time, you tend to forget some things. But by the time we are going through them again, that will help us to refresh our memory. And there might be some things that you have overlooked before, and they are very important. And with all this training aspect of the program, you will be able to catch up with those information. Okay. So to start with, I have a statement here, and the statement goes, stop thinking like an ordinary employee or like a leader. As a data analysis, as a data analyst, what this statement means. Anybody want to go first?
So to me, I believe it means that you should think outside of the box sometimes, not just thinking about what you do at the moment, the job only. You have to think about the future, like the plan B, and how you can improve on yourself.
Nice one. Excellent. Anybody want to make a try?
Okay. For me, I think when they say stop thinking like an ordinary employee, but like a leader, you should be providing solutions. So if you are working in an organization, you should not just do what is given to you. You can also look at things going on, what is needed. So you bring it up, provide solution. So everybody is looking for somebody that provides solution. So that is thinking beyond just being an ordinary employee. That's my own contribution.
That's also nice. Thank you, Amos. Thank you, Philip. Let's take one more. Then we move to another thing. And probably the remaining people will be the one, will be those that will answer the next question. Okay, thank you, Efe and Amos. Any other person want to join this batch?
All right. I want to say thinking like a leader is thinking innovative. Okay, you must be innovation, knowing that whatever you do for an organization as an analyst is going to lead them, okay, in the right direction and the right decision, to make the organization grow. So that means that you must always think like a leader. You are leading and you are, you are directing a vision. Okay, so that's an idea.
Okay. Hello? Hello? Are you guys hear me, please?
Yes, we can.
Yes.
Okay, thank you. So kudos to all those response, and that is exactly what is it. I will just add one or two more things to it so that we can have more clarification on it. Okay, just give me a moment. Okay, I don't know what happened to the Zoom before it just suddenly stopped and restarted. I don't know what happened to it. So I'm happy to hear that from you guys, and that gives me rest of mind that I'm among the intelligent set of people, and this class we will actually enjoy the class in that sense. So what this statement is actually telling us that if you are thinking as like an employee, you might be expecting others. You might be expecting somebody to tell you what to do. But if you are thinking like a leader in an organization, you will think outside the box. Like, is it Efe that said that? Something like that. You think outside the box. Like you think like the owner of the business. And that's when you can actually make the right decision for the organization. You will be thinking that what concerns you about decision making. But don't forget the importance of data analysis to the organization. The importance of data analysis to the organization is to make decisions, right? And who are the people making decisions in the organization? They are the leaders. They are the stakeholders of the organization. Maybe the head of marketing, the market manager, the operation manager, the design manager, or the general manager, all those different stakeholders, they need information from you to make the right decision. They need advice from you to make the right decision. And you will have hear this proverb that go like, if you are among 5 billionaire, you are also a billionaire, something like that, right? So if you are among 5 leaders, you are the 6th leader. But if you are thinking like ordinary employee, definitely it will be very difficult for you to operate within those leaders, because most of your work have to do with working with the stakeholder in your organization. So, and by the time you are thinking like a leader, that will give you opportunity to see things from different perspectives, like especially like thinking out of the box. It will now be your responsibility to be thinking for that organization, like from which perspective can we look into this data? They can give me and other person the same raw data, but the perspective, how do I exploit my own data? How do you exploit your own data? We also depend on which lens are we seeing the data at hand. So that's the first thing I have to give you today. So always think like a leader in any organization you find yourself. And that starts from today. If you have not started it before, I will link this back to the PJ lecture, I think, and we also do that during the course introduction lecture after the seminar, in which we use one data. Do anybody remember that we used to demonstrate the decision making in the organization based on the number of people registered for the program? Do you guys remember that?
Yes.
Okay, thank you, Rita. So if you did not think like a leader, it will be difficult for you to ask, to know the right problem to define, to know the right question to ask as far as the data analyst is concerned. Because most of the work you are doing as a data analyst starts with question. What question do we have on ground to answer? Okay, and you will see that we use the same data to answer many, many questions to the organization. So that is the first thing you need to have at the back of your mind. And I'm very sure if you go for interview today and they ask you a question like, what type of data have you analyzed before, or what type of project have you worked on before? I want to believe that we all have a project that we, even with your first 1 week with Amati IT, you have a project, a real life project that you can talk about now, because we all pass through the process, the data we analyze that day, and the data, I think the PJ also used the same data to analyze for you the last lecture. So that is a real life example, irrespective of the kind of organization, irrespective of the tools that you use. That is a real life project, and that's a real life something that you can talk about. And I can bet it with you, any interviewer will definitely ask you a question related to something like that in your interview, like what projects have you worked on, what challenges do you have from it. And if you are framing the project for your maybe you just give them one story just to have your way. Definitely, the interviewer, they are psychologist people. People who are good in psychology. So they definitely know when you are lying or when you are saying the truth, because the way you say the truth, the two are different. Okay, so that's that. Now I got a big question here. From those that have not talked, I would like you to answer this question for me. What can data analysis skill do for you or your organization and the world as a whole? What do you think? Who is going first?
Yeah. What I think data analysis does for an organization and the world is, first of all, they tend to generate data in the sense that perhaps, let's say, a Coca-Cola company want to know the rate of people that are using their product. Is it more of woman or is it more of man? So they tend to generate data, ask themselves some questions. Then in terms of correcting data, visualizing it and analyzing it, then taking action on making a profile decision. In summary, data analysis help organization know the actual people that are using their product. Or just you can still narrow it down to any other niche, but they are people that make an organization know the actual people using their product, the number of people that are participating, or just that's just it. Thank you.
Thank you, Valentine. Good. That's good. I need 2 more people.
Okay. I think I'll go next.
Okay.
So for me, as a data analyst, it helps make an informed decision in, wherever you are at any stage, as a company, making decision for better future, as in profit, for whatever it is you are looking at, at every stage in life, you make decisions, either to move forward or to move backward. But to make that, required decision, you need to be able to look at, information available in front of you. And with the help of data analysts, they structure it in such a way that you can easily make that decision without having to, go through each and every one of the information. So what a data analyst does is helps you gather all the information and present it in in a very good manner that helps you to make decisions fast and efficiently. So that is just the work of data analysts. They prepare the information for you, make it readily available, so for you to be able to make an informed decision when needed.
Nice one. Thank you, Olufemi. Excellent. I need 1 more person.
Okay, let me go.
Okay.
I think data is the lifeline of any sector at all. Any sector is important to the government, is important to the health sector, is important to every sector, really. even for us, even at home too, as small as at home, when you have to manage the budget, you need to know what your budget is, what you have spent, how much is coming in, the things you need to buy, so data is like the lifeline of like an organization or any sector, I would say. So the data analysis skill will help you analyze that data to help anybody at all, to help the government, to help any sector make informed decision concerning whatever project it is that they want to venture in. Just helps them make the next decision on what to do, how to go about it, what to cut down, what not to cut down, what are they doing well, what can they improve upon. So the data analyst would help them get that data, analyze it, and give them in a proper graphical presentation and interpret it to them graphically so they can see, understand, and make an informed decision.
Thank you so much. Yeah, that's great. That's great. Thank you, Lugemi. Thank you for Valentine. That's all the answer you provided. They are all correct.
Yeah, let me also add to it.
Okay, Emmanuel.
So data analysis basically also helps to make decisions, like everyone has actually stated. But there's what is also called predictive analysis. So basically, predictive analysis is just about looking at trying to identify future trends for based on maybe the occurrences that have happened in the past. So you're able to tell that, okay, maybe in the month of June, for instance, we'll be selling a lot of drinks, or in the summer months, we'll be selling a lot of drinks because, of course, people will be thirsty. It's the weather will be hotter and all of that. That's just an example. Then you also have what is also called prescriptive. There's prescriptive analysis too. So prescriptive analysis basically just allows you to make recommendations. That's what it does. So you might want to just look at it, to have a broader view of what I'm talking about. So data analysis is very broad. It's broader than what we all know, because I read data science actually, but data science is another ball game. Or data analysis is also because I think, from my own perspective, I think data analysis is even beneath data science, if that makes any sense. So that's what I think data analysis does for organizations, basically. Thank you.
Thank you, Emmanuel.
Yeah.
Thank you, everybody, for that contribution. All the answers you provided, they are very great one and excellent one. That's good. I would like to also add my own as a matter of fact. So, do you know that as a data analyst, you are not supposed to be poor? Whether you have job, you don't have job, you are not supposed to be poor. Do you believe that? Yeah, I intentionally go to that side because you guys have already provided most of the answers that are useful to the organization and the world. But you have not really talked about the one. I think Bola talked about the one that affects us individually by talking about making decisions at home, which is totally true. But I still have another perspective from which I am looking at it, because if you look at this last statement, it included you as a person individually, then organization, then the world. So most of the answer we have from grants is basically on organization and the world. But you as an individual, you can also make use of this skill to the maximum level. And you will see why I said that in a moment. Who know this guy? Anybody? Anybody? I can see many no in the chat area, but you can as well talk, but that's fine. I can see many no already, so I will take it that nobody know this guy. But this is Jim Simon. And it is not good for you to fully become a data analysis without know this man. That's the reason I brought him here today. James Simon is a genius when it comes to mathematics, and he has used mathematics to solve many financial problems. And if you look at all the answers we have provided to that question, basically, the organization is making investments. The country, I mean, the whole world, they are making investments. You as an individual, you are making investments. And the major goal of everybody is to have the possible and the maximum return on the investment, right? Is that correct?
Yes, that's correct.
Yes.
Yeah. Thank you, brother. Do anybody also believe that that's correct?
Yes, that's correct.
Yeah, thank you. So the major goal, the final end game is to maximize our return on investments. And the best organization or individual, anybody that have the best data analysis skill will definitely be achieving the highest return on investment. And this guy, Jim Salmon, he have been based on records so far, or based on the humanity record so far, he have achieved the highest return on investment when it comes to, I mean, there are some investment that we cannot bring to books, because personally I've achieved more than 100% return on investment on some of my investment, but those are records that cannot be printed to book because they are not on a standard level. When we are talking about standard level of investment, we'll be talking about stock market or foreign exchange and the likes, majorly stock market. Okay, so let's see. Let's listen to him. As in, let's know little about him before we dive into the journey, and let's see how he applied data science to achieve all the achievement on Earth. I've got a video on YouTube that talk a little bit about him. I think I copied the wrong thing. Okay.
Save on every range in the Oak Furnitureland January sale. Like the Dolby, now only $9.99.
What if I told you that there was an investor who achieved much higher returns than Warren Buffett, Ray Dalio, Peter Lynch, George Soros, Charlie Munger, and essentially all of the other great investors that you can think of? Not only did he beat them, his returns blew theirs out of the water. So if we look at this, Warren Buffett...
Hi guys, can you hear the voice? Is it audible over there? Please?
Yes, we can
Yes,
hear
it is.
Okay, so let me continue.
What if I told you that there was an investor who achieved much higher returns than Warren Buffett, Ray Dalio, Peter Lynch, George Soros, Charlie Munger, and essentially all of the other great investors that you can think of? Not only did he beat them, his returns blew theirs out of the water. So if we look at this, Warren Buffett's annual average return is 20.1%, Dalio's 13%, Lynch 29.2%, Soros 20%, Charlie Munger 19.8%, Jim Simmons 66% average return. Out of all of the investors that I've studied, no one has got a yield anywhere near close to his. And this is not just over 1 or 2 years, this is over the past 31 years of consistently just destroying the market. To put that into perspective at how impressive that is, if you invested $100 and were able to achieve a 66% return every year, after 31 years, that $100 would be worth $665,810,000. To regularly achieve something that high is unheard of until Jim Simmons came along. But how did he do it? Jim Simmons relies on quantitative analysis to decide the trades he makes. He's a numbers man. He was a math genius growing up, getting a bachelor's and PhD in mathematics when he was young. Just for some reason, math turned him on. Now, the old excuse is, when do you ever use math in the real world? Well, Jim Simmons was about to answer this question in a big way. He used his math skill to become uber rich. Originally, he used it to break codes with the National Security Agency, as well as teaching at MIT. Although this paid good on a relative scale, this is not generally the profession you'd go for to amass a fortune. He then made the decision that he wants to step into finance and trading, where the real money is. Now, naturally, Simmons keeps his trading secrets behind closed doors as much as possible. Of course, if you had a fund earning a 66% return every year, making you a multi-billionaire, you probably wouldn't tell your secrets either. However, there is quite a bit that has gotten through the cracks on his trading strategies. So in this video, we're going to go over 7 of his key strategies that Simmons used to trade in the market. Back in 1982, quantitative analysis was not a thing. The models that we see traders use today, no one had thought of. So people generally relied a lot on perception and homemade systems to trade. For the first 2 years, Simmons did just this. He used ordinary, fundamental, and technical approaches to trade in the market. A lot of it was based around intuition and instinct.
No models for the first 2 years, like normal people do.
It was a similar approach to the way everyday regular traders trade in the market today, except unlike most, Jim actually made money because 1, he was a math genius, and 2, because back in those days, there were so many more opportunities, less competition, less computers trying to arbitrage the market. So he was able to make a decent amount of money this way, but at least according to Jim, he felt that it was mainly luck and also emotionally draining, not knowing if you're going to be making profit the next day or not.
We were extremely successful. I think it was just plain good luck, but nonetheless, we were very successful. But this was a very gut-wrenching business. You know, you come in one morning, you think you're a genius, and the next morning you come and you feel like a jerk, the market's against you.
He disliked the emotional side of trading, and he wanted to find a way where you could almost guarantee that money would be made. Kind of like at a casino, the house is always going to profit because the odds are rigged in their favor. They don't get emotional, they just want you to keep playing. Simmons aspired to create a model like this, but for trading in the stock market, where if you just keep trading, you're guaranteed to win because the odds are in your favor. In order to do this, Simmons needed a lot of data. For a quantitative analyst, data is obviously key, and he would gather information on everything.
Weather, annual reports, monthly, quarterly reports, the historic data itself, volumes, you name it, whatever there is. We take in terabytes of data a day.
So his team would gather all of this data up, backtrack it across history, and search for anomalies. Where is there something consistently odd happening that I can profit from? And the anomaly might be something like, every time the date is leading into Christmas, the stock would increase in price. Most investors would try explaining the reasons why. Simmons did not care why, he just cared that the data showed it consistently happened. And once he found the anomaly, he simply would buy the stock leading into Christmas and sell after Christmas, each time making a profit. That is a simple example of anomaly trading. But Simmons would do this across thousands of data sets and search where the abnormalities were that he could benefit from. Secondly, he and his team would look for trends. This was an approach that worked very well in the early days of trading. The best place to go find trends, at least back in the day, was in the commodity market. Copper, gold, silver, oil, corn, wheat. These things would often follow a pattern. So here's a typical example of the price data of a commodity for a year. We'll say it's wheat. Simmons would zoom in on a smaller time frame, say 20 days, and he would notice that the commodity is trending. Maybe it's trending upwards because less farmers are able to sell during this time, or trending downwards because of oversupply. As we said before, Simmons doesn't care on the reasons why. All he cares about is that it is happening and how he can profit. So if it was trending upwards, he would trade it and buy, and if it was downwards, he could short it and make some profit on the way down. This system worked very well for him early on, even though it sounds quite easy. But after a while, people started to catch on with this method, and it became more and more obsolete.
Years ago, such a system would work. Not beautifully, but it would work. So you'd make money, you'd lose money, you'd make money, but it's a very vestigial system.
Simmons would need to upgrade his strategy if he wanted to keep making money in the market or risk going bust.
Energy supplies don't want you to know about this trick to warm up houses for practically zero cost. This space heater is...
In the book, The Man Who Solved the Market, Gregory Zuckerman stated that Medallion, which is Simmons' flagship fund that averages the 66% return, earn profits from trending and reversion predicting signals, especially a one called deja vu. Reversion in terms of trading is when a price of a particular stock will revert back to the average, or it will revert back to a particular metric. Sometimes it will fall below the average, sometimes above, but the job of Simmons' team will be to profit from these fluctuations. For example, you would place a stock like Apple in the algorithmic model. Then it would look at a bunch of different data points, maybe revenue, book value, PEG ratio, and the price to tangible book value. And next it would start to look for patterns. Where would it see the same things happen over and over again? Where would you get that feel of deja vu? And maybe the model would spot that over time, Apple generally has a price to tangible book value of 43. Sometimes it would dip below, sometimes above, but the pattern would always revert back to 43. Again, Simmons would see this, he wouldn't care about the reasons why, he would just know that it happens. And he would take advantage of this pattern. His firm would simply make a trade when the price goes below 43. It reverts back to 43 and he makes some profit. If it goes above 43, he could short the stock, and they would just keep doing this until the pattern would change. That's a basic example of reversion predicting signals. And maybe in the early days, it was as simple as just a few data points that you can profit from. But as more and more traders started to click onto these techniques, Simmons would develop more complicated models to profit in the market. Instead of just simple pairs, he created a fund that involved complex signals and equity trades. It would go through all data it could find on a particular stock, correlate multiple variables, and then use machine learning and their models to find irregularities where they can make profit. In order to create models that could take in such vast and complex amounts of data, then find patterns and then profit, Jim would need to find a team of very smart people, like the Avengers, but instead of helping the planet, they would help solve complex trading algorithms. People with PhDs, doctorate degrees, top 1% of IQs, people who could code. Instead of going for people on Wall Street and with finance backgrounds, Jim looked to universities. He started hiring people with doctorate degrees in math and physics, astronomers and statisticians, people who could solve complicated problems. They didn't necessarily have to have a finance background. In fact, he didn't want this. Simmons said, the important thing was that they were very smart. I like to say that you can teach a physicist finance, but you can't teach a finance person physics. And this great team of what can best be described as nerds would begin to crack the codes for trading in the stock market. And the smart thing about Simmons' strategy was that he didn't hire these people as employees, he hired them as partners. The only way that you can be an owner in the Medallion Fund is to be employed there. So this way, all of these very smart workers are incentivized to make as much money as possible, because the money would not just go to a company, but to themselves as well. So you have hundreds of these PhD level geniuses, all with one incentive: to make as much money in the market as possible. This was a recipe for success. During the mid-1980s, a top researcher of Simmons' team began identifying ghost patterns in market prices. So the project was based on similar code cracking that Jim and his team had worked on at the National Security Agency. The main idea was to look for patterns that others failed to detect and then profit from it. The Medallion Fund would feature a collection of a minimum of 8,000 signals based on the short-term patterns of the entire batch of scientists who work for Medallion. The fund then leveraged these signals, aka they borrowed money to trade in the market countless times per day. Reports say that they borrowed around $17 for every $1 that they invested. And this was a bit of a secret to their success, the fact that they didn't even have to use their own money. They could borrow the money, quickly make some trades and profit, and then return the borrowed amount back, or just do the same thing again and again. The co-chief executive of Simmons' company said, "On an unlevered basis, aka not borrowing, our models produce modest returns with very low volatility." Borrowing money helped change these returns into something that wasn't modest at all, and basically put the company's returns on steroids. The beauty of hiring PhD nerds over regular investors is that they would have one focus on the numbers. Astronomers, physicists, mathematicians, they don't worry too much on the emotions of the market, what investors are saying, the strength of the brand, or anything like that. No, to them, it's kind of like a science experiment or putting together an equation. The only thing that matters is the numbers and making sure that they work. So instead of solving problems on how to get to space or the force needed in a rocket or solving a physics calculation, they would solve trading algorithms. Just like a science experiment, you just need to keep changing the variables. Does this one work? Does this one make profit? No, let's try another. Does this one work? No, let's try another. Does this one? No, let's try another. And they'll just keep fiddling with the equation and the variables until they find something that makes them a profit. By their very nature, they were perfectly suited for this type of work. As Jim Simmons was growing his fund, so too was the rise of machine learning. So machine learning is the ability of a machine to use information to improve performance on some set of tasks, whether that task be email filtering, speech recognition, chess, or finding profitable trades in the stock market. Just like with chess, the machine can analyze thousands of different moves and the consequences of making each move. It can predict if a move is beneficial for the player or if it's going to make the position worse. And it's the same thing with a stock. Machines can test thousands of different moves and see which one leads to making money.
It's what's called machine learning. So you find things that are predictive. You might guess, oh, such and such should be predictive, might be predictive, and you test it out in the computer and maybe it isn't, maybe it isn't.
The beauty about machines is they can test almost infinite amounts of data and theories. In the time it takes for a human to test one thing, the machine can do 1,000,000 tests. And Simmons realized this very early on, so he incorporated machines into his trading strategy, which gave him a huge advantage over his competition. So those are 7 strategies that Simmons used to become what he is known as today, the greatest investor on Wall Street and also the most successful hedge fund manager of all time. So if you're currently a
Hi guys, how's it? You guys follow the video? Yeah, can see many responses on the chat. Yep, I need just 2 persons to just tell us what they learned from the video, then we move to the next thing. Anybody? Going first?
For me, I think what I can pick from the total thing is that he learned at a very early stage when people do not really take cognizance of facts and figures. He learned to differentiate emotions or deep analysis by looking at the stats and making informed decision right from that early period. And that has actually helped him. If you see some of the part of the because he said documentary there, or he was saying that he didn't really care about the reasons for that drop in price or analysis, but he just look at the figures, the trend. He bases predictions on the trend, and once he see it as a pattern, and then he take advantage of it, because with the pattern he can tell when it's going to fall and when it's going to rise. So, and that's all you need in stock market actually. So he has been taking that advantage and makes more money, and to the extent where he goes into the machine learning and all that, he just keep improving on that, the same strategy, making more money to the extent where he has to employ a lot of people. So that's that's for me, that's what I think I actually get from that.
Excellent. Thank you so much, Olufemi, for that brief overview of the lesson we learned for the video. Who want to support Olufemi?
I think the historical data and the trend, the pattern, there's the insights is able to derive from those data, enable him to make a decision to make profits. So that relates to like data analytics, look into the data, get discover, create an insight, and from there make positive decision for the organization. So just in summary of the video relating to the data analytics job, so you can get an insight on the data, both historical and train pattern, gain insight, and make positive decisions.
Thank you so much, Rita. That is very correct. Thank you, Rita and Olufemi, for giving us the overview of the lesson that we learned from the video. That's great. And I will just add a little to it, just to share more light on it. So in short, we can see that Jim Salmon make all his achievements basically based on data. And if you notice, there is ongoing phenomenon now that data is the oil of our generation now. So I don't know, maybe I've come across a phrase like that, that data is the new oil now. So, which is totally true, because the whole world now, they are now building organization strength on Jim Salmon principle. Like, if you can analyze data to study what the data is telling you, you can always make a good decision with less risk in time of investment. And that is what every organization have realized at the moment, which is making the data analysis industry grow at high speed at the moment. So that's it. But if data is that important, before I move to that, I should also tell you that, okay. Yeah, so if data is that important, there's another statement that also tells us that, but don't analyze wrong data. So do we understand what the statements mean and why that statement is important? Don't analyze wrong data. Anybody want to go for that?
Okay. I would say the statement here, don't analyze wrong data, can be costly to the organization, because if you use wrong data to make predictions, which is something that is going to affect the company, because you are using wrong data to give to management to make decisions, and those decisions can really bring down the company. So that is what I get from that.
Thank you, Amos. That's totally correct. Ayodeji, do you want to support Amos?
Yes. Okay. For example, on Thursday, something happened. We were analyzing in the class. So we use percentage, to make I think an analysis. And I asked, if we use percentage, can we also use ratio? But at the end of the day, using ratio pointed us to a different thing entirely. Maybe we are doing, for example, like VJ explained that they say, if you are going to use ratio, that will be maybe because we want to do some budgeting or planning for each classes. But it will not apply to what the question we are actually, being asked. You get it? So sometimes we can't, if we use the wrong data, we are going to get the wrong, we actually analyze, but we are going to get the wrong answer. You get it? So that's it.
Thank you so much, Ayodeji. That's totally correct. Like, if you garbage in, garbage out. If you use wrong data, you get wrong results, and all your efforts are wasted. So who want to waste efforts to doing something? Nobody want to waste effort, right? So definitely we must not analyze wrong data. So in order not to analyze wrong data, there is a process that you need to follow before you even start analyzing your data. And that is what we know as data wrangling and pre-processing. Have you come across these two words before? Data wrangling and pre-processing. Who want to tell us what they mean? That two statements. What's the difference between them? I need just one person.
Okay. Data wrangling should I say, it can be defined as the process whereby we remove errors, we detect error and remove them. Then pre-processing can be defined as the way we understand and process data. I don't know if I get it. Thank you.
Thank you, Valentine. Yeah, you actually get it. I know what cause, I know what as in why you are confused with the second one, because they are two different things, but if you want to define them, you still define them the same way. But the major difference between the two is that, like you said, it's the process of removing, transforming raw data to a more usable data. We know that we need data to make informed decision in our organization. We need data to maximize our profit in the organization. So now the next thing is if we have the data, how can we ensure that we are not analyzing the wrong data? That is where these two processes comes in, the data wrangling and pre-processing. And I want to assure you that if you master this process very well as a data analysis, you have high percentage to be successful as a data analysis. Why? The reason being that 80 to 90% of everything you will be doing, let's assume they gave you a project to do now. 80 to 90% of all the work that you will do on that project as a data analysis lies on data wrangling and preprocessing. That the only 10 to 20%, the remaining 10 to 20% is for the remaining process that you'll be doing. If you follow the process, the data analysis process. So most of the work that you'll be doing is in data wrangling and processing. So it is time consuming. If you are going to spend a month on a project, I can assure you that you will spend like 20 days, even maybe 20 to 25 days on wrangling and preprocessing. So in short, what I'm trying to let you know is that everything that we'll be discussing under this process, try your possible best that you master each and every one of them, because that's where the tedious work of data analysis is. Okay, so how can we achieve this process? There is no more different, like Valentine defined it for us. It's as simple like as that definition. It's the process of transforming raw data into more usable formats that we can use for our analysis. But what is the major difference between wrangling and preprocessing? Preprocessing is mostly for machine learning algorithms. Like, if you want to analyze data as a normal data analysis, you can use data wrangling and stuff there. And if you want to use it for if you want to use the data for machine learning, that means you have to carry out pre-processing. The two of them have similar stages involved, while the way of doing it is only the way you do it that is different. So we'll be treating them together without separating them. But just know that as a normal data analysis, you are focusing on wrangling. Why? If you are moving more in depth, maybe by the time you are doing data science and the likes, you are advancing your work, definitely you will need to go in depth to data preprocessing, in which maybe the data you want to analyze is not for, maybe the data you want to use is not for organization purpose directly. Maybe you want to prepare the data for machine learning training. Maybe they want to train a particular machine learning for a model. Then before they can use that data for the machine learning, you have to pass through the preprocessing stage. So that's the major difference between the two. Thank you, Valentine, for that answer. Okay, so what are the processes involved in this in data wrangling? The first one is data connection. Data connection. So why it is important for us to talk about data connection? We have known that the data is important, but how do organizations normally get this data? You can see from the story of Jim Salmon. Jim Salmon used to buy his own data, right? Because Jim Salmon did not have any company. He did not have anything he did not have any customer. So he cannot get primary data from his own organization, because the organization is not interacting with customer. They are just trade. So he used to buy data. So I will later show you some platform. You'll be wondering why are they selling data? Yes, they are selling data. I will show you some platform where they are selling data. Now, this is where you need to understand individual organization that you want to work with, because you can see we have different, if you are looking at this picture, we have different individuals on this picture here. And if you notice, the position in which everybody is will determine who they are connecting with. So let's see each of these, all these small picture here, like an organization. And those links, let's see it as a link from which they are getting their data. And you will observe that the position in which a particular organization is determine the kind of data it gets. So you can see that each of these people, like I said, let's represent them, let's see them as organization. Like we have many organizations on ground, and each of them are getting their data from different sources. So you can be a data analyst to Amati Paiti, and Valentine can be a data analyst to another organization. But you guys, okay, Emmanuel, okay. So you guys might be a data analyst, but different to different organizations. That means the data you'll be dealing with in your organization might be different from the data I'm dealing with from my organization. Because where are we getting the data in my organization, and where are you getting your data in your organization? So if we are getting data from different sources, definitely the data we are dealing with might be different data entirely. So some industry have similar data. Maybe you are into e-commerce, you are doing B2B, you are doing data analysis for B2B. To some extent, we have know all the kind of data that B2B will be using. You are doing data analysis for healthcare. To some extent, we have know the kind of data they are using. So different companies for under healthcare sector, they might be using different, they might be using similar data source. Then if it is retail, all those different sectors have different source of the data, and the organization also different from organization based on where they are sourcing their data. So what are the examples of where you can source, the organization can get this data? So like the first statement that I displayed for you during the beginning of the program, that always think like a leader, not just like ordinary employee, because that's where you can able to think outside the box. So now you have to be thinking where your organization data is coming from. And if you are thinking about as an employee, you might not think like, well, what concern as a normal employee, what concern normal employee has from with where the data is coming from. But if you are concerned as a data analyst, because that's what will give you some pre-knowledge of what can happen, what can wrong in that data that you want to analyze. Okay, so we have various means in which organizations get their data. Maybe via the email subscription, in LinkedIn, maybe the LinkedIn account, in people that are interacting with the organization LinkedIn account, people that are interacting with organization Facebook accounts, then web scraping, service, as the data can be in Excel, can be in email, can be different maybe research work reports that have been the reports from the industry. The data can come from different sources. So you need to understand the source, your organization data source. Okay. And there are many sources, like your data can be a web page data, maybe how people are interacting with your the organization website. Web scraping, structured data, that structured data may be in Excel or JSON format and the like. And it can be from cloud. Maybe your organization is using cloud. Maybe they host their application in cloud, or their server is in cloud. And you might be getting your data from cloud. And some of those, we have many cloud provider like Amazon, AWS, Azure, and the likes. So, and it can be from API. Maybe your organization subscribe to API for a particular API for data. So maybe your organization subscribe to a particular API for data. Your data might be coming from a particular API. So those are different means in which the organization might be getting the data. So it's your responsibility. You need to find out where the data is coming from. Like you need to know where the data you're analyzing is coming from. So because all these data have different traits. For instance, the data from API, who can tell us a little thing like just like few seconds, what you know about data from API, how will that kind of data look like? Or in which format, let's just make it simple like that, in which format a data from API we want to go for that?
I from what I've learned in the past, I think it will be in JSON format.
Thank you. God bless you, Amos. That's correct. So mostly it will be in JSON format, and it can also be in XML formats. So it depends, but mostly it's always been JSON. XML is even JSON, but advanced JSON format. So that's it. If the data is in JSON format, you cannot analyze that kind of data directly, right? Then if a data is from web scraping, what type of format that type of data might be? Who want to go for that? Anybody? Web scraping.
I think web scraping, I think CXV, and then also this it can also be in JSON too, I think.
Yeah, that's correct, because it can be in different formats, because web scraping, when you are doing web scraping, it can be everything that is on the web. It can be picture, text, number, and like, so it might not be in the web structure data. It can be different formats of data. So, hi guys, can you hear me now? No?
Yes, okay.
Yes.
Okay, thank you. So that is for data source. You need to understand the data source. And since we are seeing that different data source might have different formats, so it's very good for us to treat our data. Okay. So that's the first stage of data ramping. So data connection, and once you collect the data, you have to understand where the data is coming from, understand the data format, then move to the next stage. So what is the next stage? Before we move to the next stage, I will also show you some data. Okay, it's part of the data source. All those ones that we have mentioned might be maybe the organization are doing those directly, but there are also some organizations that sell data. So part of them is Cognizant, Penteam. So I'm just trying to open those pages so that we can just see them briefly. So all these organizations, they are data vendors, they are data providers sending data to organization. And probably you might later work with one of them. So this is another one. They are later vendors. So organizations just need to subscribe to them and get that based on the kind of data. So like since they deal with B2B data, so all your interaction and how do people get data? How do all these organizations get data? They get data from your interaction with internet. You go online, you do something on Facebook, on Instagram, on Amazon, eBay, all those different interaction with internet. Those are where they are gathering their data gradually. And once they have large volume of it, we start sending it to organization. Organization will analyze it to make their decision. So after data connection, then you need to carry out data assessment. So what's data assessment? Does anybody want to, just one person, please? Data assessment. Who is going for it?
Like trying to test the reliability of the data, maybe the source, if it's genuine, or and trying to say what if it contains what you really want for what you want to do.
Yeah, you get it right. Thank you, Amy. That's correct. So it's just to assess your data and see if there's anything wrong with the data before you start your analysis. You know, you have collected the data, and before you do anything on the data, you have to carry out the assessment on that data to see and what are the things you need to check. So if you use this framework, we make the work easier for you to know if there's anything wrong with the data. Well, firstly, check the accuracy. Is the data accurate with what you are expecting? Okay. So if the data correct, like Eva said, is the data correct? That's the first thing you need to check. If correct accuracy, then you move to consistency. Is the maybe, you know, in the table, maybe there is some table on in your data or column or row that are not consistency. So if you analyze a rows or column that is not consistent, it will be causing problem during your analysis. Yeah, you need to check the consistency of your data. Then you need completeness. Is the data complete? Maybe some rows are missing or some columns are missing, some data are missing. You need to check if there is any missing data. That's completeness. The integrity. Is this data adhered to, is this acceptable? Is it accepted data formats? So you need to check the integrity of the data. Is it something that you can use? Is it something that you cannot use? Then equivalence. So like your data, you need to check the equality of the data. All the data is okay. All the data have equal value in time of maybe test their column, rows, and the data form. Which format is this one? Are they in line with each other? All those things need to be checked. So in short, when you are carrying out data assessments, you can use this framework, in which if you check these three in these 5 boxes, definitely you're able to clear all the error to some extent. So if the accuracy is not correct, what can you do to correct the accuracy? If the consistency is not okay, what can you do to correct that? If completeness is not okay, what can you do to correct that? If the integrity is not okay, what can you do to correct that? Equivalence is not okay, what can you do to correct that? Okay. So that's the second stage. And the third stage is data cleaning. So in the second stage, you have carried out the assessment to see if the data is okay to use or not. But now let's assume we have seen that the data is not okay, maybe that is incomplete, it's not complete or consistency or accurate or equivalent, and it can be multiple of any of these situations. So what can we do? The next thing is to move to data cleaning. How can we clean the data? And by the time you want to clean the data, if you also follow this framework, definitely you'll be able to carry out a perfect data cleaning. So you can see, cross-checking all these stage, like all these concepts, cross-checking your data that is satisfy all these checklists can be a tedious work at times, and that's the reason most of the work you'll be doing will be on this data wrangling stage, like the early stage of your data, like finding all these problems. Once you able to discover those assessments issue with your data, then you need to do the data cleaning. And what are the things you need to be checking out? Is the data you want to use is up to date? Is there any duplicate in your data? Check all the ID and ID who want to share more light on ID in our data. What's the importance of ID? This
The ID is like a unique identifier.
yes. That is excellent. But why do we have it?
So, and distinct to distinct the different roles. That's to show that the like to give each rows a different unique identifier.
You mean to differentiate each individual data from each other?
Yes.
That's correct. Thank you so much. Then, if we now have a duplicated ID in our data, what does that mean? If we have a data with the same, if we have two data with the same ID, what does that mean?
That means that there is a repetition of the same data.
Can we analyze that type of data?
No, we have to remove it.
We need to solve the problem, right?
Yes.
Okay, thank you. Though that aspect is tricky, so I will now to share a little bit more light on that. Why it's tricky is that you just go for remove. In most cases, it will be removed, but in some cases, you need to find out what lead to that duplication. Do you get me clear?
Yes. Now,
Because if you think that is it, they have two ID, the same ID, and there is probability that those two data might belong to different individuals. Do you understand that?
Yes, I do.
If it belongs to two different individuals and you just remove one, definitely you have removed that person data.
Yes.
If it's a duplicate, definitely we will remove it. You want to say something?
Yes. In the case where you don't have like a data engineer in an organization, so how are you going to know how are you going to solve an issue like that? I know in most cases you get your data from the data engineers. So when you get the data from the data engineer, that means you can go back and ask to find out if the data, where the error is coming from. But in situation where you don't have a data engineer to confirm something like that, so how will you go about it?
Thank you for that question. That is a brilliant question to ask because it will happen to you during anytime when you are working, maybe even in your interview, anything, it can happen anytime. You can come across a challenge like that. And thank you for asking that question so that everybody will benefit from the question. So there is something we call domain knowledge. Do you know what that means?
Like an expert.
Domain knowledge means that if you are working for Royal Mail, for example, right? For example, if you are working for Royal Mail, so if you have worked there for like 5 years, you will have known much about the organization. You will have known more about the data they are dealing with, right?
Yes.
So let's assume somebody type wrong postcode. If the postcode is wrong, you will know based on your domain knowledge.
Yes, yes.
Because maybe you have already know that postcode is normally six number or six. It could be number or alphanumeric. So if it is 6, and you see something like 4 or 5. You know, the only thing that will, if it is a new data analysis in a new data analyst in that domain, in that organization, maybe the person have not worked in that domain before. The person might not know that it's an error, might think that maybe the data is still correct, right?
Yes, that's true.
But your domain knowledge will allow you to know that this data, this number is supposed to be 6. Definitely there is error here. So that type of data, you can decide to remove it or to go and find out if you can able to get the complete the postcode. Just using postcode as an example, you know that can happen in different perspectives.
Yes.
But the main solution there is domain knowledge. If you don't have domain knowledge, maybe you are new to the organization, you don't have domain knowledge, you can ask a senior analyst in that organization who, by the time you have anybody who has spent 5 years in a particular sector, it might not be the same organization, but the same sector. Like we use Royal Mail, for example, now. Or let us say we use healthcare, maybe a particular care home or NHS. We are working for a particular hospital before. If you also move to another hospital, that it is still the same domain because it's still the healthcare. So you will be able to still understand. But if you got transferred from healthcare to e-commerce, that's a new domain entirely.
No.
So you might not have new domain knowledge yet. So domain knowledge is very important in data analysis at this process, at this stage, at the stage of data wrangling is very, very important. Because all these things is not, there is tools that you can use for all of them. By the time you start doing Excel and Python and with PJ, it will be taking you through all these things with your tools. But there are some that you cannot use tools for. You just need to go through the data manually. Like issue that you raise now, you cannot use tools for something like that. You have to go through it manually, and that's part of the reason why this stage always consumes the most it consumes the higher percentage of all the things we'll be doing on a particular project as a data analyst. Is that clear to all of us, please?
Yes, it is.
Yes, it is.
Okay, thank you. So you check the ID, missing value, there is a missing value, the same thing goes to them. Then numeric outlier, maybe there's miss of number and alphabet and the lies. You need to check, define and valid output. So those are the checklists for data cleaning. So you need to check this. These are the major ones. For all the data you want to work on, you need to check these 6 things in your data before you go into it at all. So all these things, it takes you to do, as in, let's always revisit this stage every time. As a data analyst, always revisit, even if you are going for your interview, if we did not remember to tell you, I've just passed the information to you. Now, this stage that we are, and we cannot finish it today, we'll see that we'll continue it next week, but take it very, very important. Everything that you want to be doing as data analysis, most of it is at this stage. Okay? So the next stage we'll be moving to after data cleaning is data transformation. Who can give us like a brief explanation about data transformation? Let me identify if somebody have not talked here today. Let me almost everybody have talked. You guys are really doing a wonderful. Yeah, that's good. Almost everybody have talked. So anybody want to go for it? Fine with that. Anybody? Data transformation. Who's going for that?
I'm trying to use my I just started using Power BI. So I know when you have either load or transform. So when you transform the data, it's like you want to edit to carry out cleaning. You can edit the data and carry out cleaning on the data, remove duplicates, all those. That's the Power BI idea, but I don't really have the full explanation.
Yeah, your explanation also is also good because at least you said you repeat that statement.
I think what I can just add to that is I think data transformation is where you are changing. Let's say you got like changing the format of the data, like present it in a different way, like maybe taking from one Excel to Power BI, or you are taking from I might be wrong, I'm not sure. Maybe that's where you use the limiter and all that to convert it to a different format, and then to be able to.
Actually, you are in line. Like that's what it is. Like it's the process.
Can
Anybody
I
want
quickly
to?
add something?
Valentine, you
Or
want to
is
say
it okay?
something?
All right, yeah. Just want to just tip in one or two.
Okay.
Data transformation, according to my knowledge, is all about um, converting, transforming raw data into useful format so that we can be able to analyze it and process it for better results. I think, yeah.
Yes, excellent. That's correct. So basically, that is what data transformation is. If you notice, we have discovered different issue at the stage of data cleaning, and probably we might have correct all those things. But the work did not end there. We still need to move to data transformation because the format or the form of data account might not be the best options for the kind of results that we want to get. So if that's been the case, we need to transform that data from that particular form to another form that is suitable for what we want to analyze the data for. And we have various means of doing this. We have different techniques that people normally use to do this. And the techniques you will use might depend on the goals or the objective or the projects you are working on. Okay, so we have data smoothing, data generalization, discretization, normalization, aggregation, attribute construction, and the likes, and we even have more of them. And we'll be taking those techniques once after the other and put light on them. You guys have a little assignment like homework, like just a brainstorm today that you work on, but I will share that with you after the program. Okay, so in short, that's what data transformation is. All you guys will get it right, and that's what it's all about. And let's start looking into, we are talking about stages involved in data wrangling before, and we are at stage 4 now. Data transformation, but we cannot leave data transformation to another stage because we have many techniques involved under data transformation. So next week we move to the other stage. That stage we'll be moving to step 5 under the process. But let's look into some of the techniques of data transformation, and this will give you better understanding of what data transformation is all about. Okay, so the first of them is normalization. Anybody want to give attempts what normalization is all about? One person, please. Everybody understand normalization? Not yet.
I would say something.
Okay.
I'm not sure. Yeah, like when I did my master's project, then I remember after getting all the, we use the survey method, you get all the details you want. Then I think there was a time I had to start using 0 and 1, maybe like yes or no, but we can use yes and no into the tools, but you have to use it in terms of numerical in numbers. So like maybe your yes will be 0 or your no will be 1, something like that. I'm not sure, but I'm just trying to remember if that is what it is.
Yeah, correct. So though you might use it in different contexts, the yes or no is familiar. I think more maybe SPSS. I don't know the type of tools that you use, but I know that
Yeah,
scenario is on
SPSS.
SPSS, right?
Yeah, exactly.
Yes,
Right.
yes.
So it's similar, kind of similar, but in this case, it's not about yes or no. It could be any number, it could be any kind of data. But what we are trying to do is that we want to scale that number within 0 and 1. And there is a process in which it's just a little calculation. And all this calculation, you can do it say on Excel or Python or any other tools that you are familiar with. But I will show you the mathematical approach to it so that you will have a deep understanding of what data normalization is. But basically, if you look at the age here, you can see that we have different type of age here, but we normalize those age. This is the normalization form of the age. You can see that we have some at the left side, some at the right side. So this one are the first one, because I don't know, maybe my right is your left over there. So I want to be careful with the one that I call left or right. But the first one, you can see where my cursor is. This is the normal data that you got. But before you analyze it, maybe the condition, maybe the goals or objective need you to transform that data using normalization. Then this is what you get. And if you notice here, you see that all the number now we have transformed them to something like from 0 to 1. So the minimum will be 0, while the maximum will be 1. So we have rescaled that number. And one good example of how you can understand this normalization is we all use graph in our secondary school, maybe physics, practical lab, and the likes, something like that use graph.
Yes.
Yes.
The X and Y axis, yeah.
God bless you. S and Y, and when you have your data, you want to plot your S and Y axis, you need to scale the S and Y axis, right? And you are allowed to choose any scale of your choice. Maybe some people might choose maybe one in each box to represent 1, or each box to represent 10, or each boxes to represent 100, and like you can scale. So something like, but here we are scaling it from 0 to 1. In which 0 is the minimum and 1 is the maximum. So that means the highest value we can have in our data will now be 0, between 0 and 1. But later on, by the time you are going deep into the study, you'll be understand scenario where you need something like this, especially like if your data is to be analyzed, like it involves machine learning, you might need to use something like this. And not only machine learning, there are many reasons to use something like this, because they provide more insight on the data that you are working with. So if the normal data will give you, if you use normal data to analyze, maybe it give you accuracy of 50%. If you normalize the data, it might give you accuracy of like 60, 70, 80%. You can see that that gap can even make us decide to normalize the data. Okay, thank you guys. So to normalize the data, this kind of simple formula for it to standardize the value. With the value you want to normalize minus the minimum divided by maximum minus minimum. So by time, for instance, let us know we pick a number here, we pick this. So that means 20, that's our value here. Okay. Then minimum value from the data minus minimum value, that is the minimum on the list here. So minus minimum, then divided by maximum minus minimum. By the time you do that for all the data, definitely you come up with something like this for age and salary. So that's a little, as in that's the basic of data normalization. Okay. Then we also have data standardization. They are kind of similar, but they are not the same thing. They are different from each other. So if you are doing data standardization, you need to calculate the mean, and then the formula for mean. You need to calculate the standard deviation of the data. And what it means to you is that if we have this data, this same data, we need to calculate the mean of all these of this column, this particular column. For each column, we need to calculate the mean using this particular formula, then standard deviation. Once you have those two, your work, you have finished your work already. So you just need to come to standardization formula, which is for vector value, which is the particular value of the number you want to calculate for, like this one. Let's actually choose 20 here, then minus the mean, whatever results you get for mean, minus the mean divided by whatever you get for the deviation. So that's how you can get your standardization. And this example of it, this is the data. And once you calculate the standardization, you can see the standardization value here. And this is the maximum minimum scale, the one for normalization. So, and there are a different type of normalization like that you can do. But basically, those two are very important, the normalization and the standardization. So your assignment today will be based on the standardization, but we are coming back there in a moment. So that's it, standardization. So in most cases, you can see standardization is not 0 to 1. It can be, but basically we are still reducing the volume of the value of the number to the minimum level. You understand them by the time you are using your tools better. Okay, so that's normalization and standardization. They are both under data transformation techniques. And let's move to other techniques and see what other techniques that we can use. Let me start from the beginning. So the next one is encoding categorical data. And what do we mean by this? Anybody want to give a try? To economize our time, I will be speeding now. Let me just go through everything with us. Okay. So encoding categorical data. What this means is that you might have some data in text form. Maybe type of food or type of drink or type of month share. It could be this data, they are in text form. And you want to analyze the data with machine learning. Machine learning, the machine might not understand text. That means you need to transform that text to binary number. And what do I mean by binary number? 0 or 1. That's any communication, you are writing Python, you are writing Java, PHP, anything. At the end of it, all your code will be transferred, because we are calling ourselves a programmer that we understand programming language. No, that's not a programming language. The language the computer actually understands is binary number, 0 and 1. Okay, so but we have compiler that can interpret our code, our program to computer language, which is binary number. Okay, so I'm not saying Python are not programming language, but I'm just telling you that they are not the real language the computer actually understand. It will still, there's still something that will do the interpretation for the computer to understand it better. Okay, so that's that about encoding categorical data, like data that maybe they are in tests, maybe they use them to categorize some maybe type of food. If I say food, food, by the time we want to be list food, they will all be tests. Orange, rice, beans, and like they are all tests. But if you want to use this data, want machine to work on this data, definitely we need to transform them to binary numbers, and that's what this is all about. And this is a typical example of them. You can see country, New York, Boston, Chicago, this list of country, right? And list of country, the machine will not able to understand this. And if we want to transfer that, encode it, you can see the first stage maybe doesn't mean that you must pass through this stage, but straight away, the middle one, you can see they transfer it to 1 to 0. So this part, New York, there's no rules here. And what I mean by there is no rule is that you can see if they are more than this, the table will more than this. You can see that's the reason we do this first stage. The first stage is to list the future and encoding, that is the list of the 1, 2, 3, 4, 5. So that this 1, 2, 3 to 5, I'll let you know that you need five rows here. If there are 7, this row will be also 7 because you need 0, as in the 1 or 0 should be 7. Do you understand what I'm trying to say there? Anybody understand that?
No, I don't. No, I don't. Can you please come with the explanation again?
Okay. Now we have how many lists here? We have category, this 5 country here, right? So for us to start our coding, first of all, we need to list the future. This, you can see this table here, future, then we list all of them. New York, Boston, the same thing, the same list that we have here. But what we want to do now is encode that, okay, New York is number 1, Boston number 2, 3, 4, 5, 6, 5. If they are more than that, we continue list them. But why do we do this encoded? The reason is that for us to know the number of rows that we need to have here. You can see the first one here, the first encoding here, which is New York, have how many rows? 1, 2, 3, 4, 5. So it is 1 with its 4, 0. But let's assume this list here, if this table, if it is 7, how many rows are we going to have here?
7.
You have got it. So that's it. If the list of the future here, there are 10, how many rows are we going to have under New York?
10.
10. That means how many 1?
Only one.
Yeah, just
1.
Yeah, other 0. Yeah.
Oh, that's 0. That's it. Is it clear to all of us now?
Yes.
Yeah. So
Yes.
I think you can explain this concept now. Encoding categorical data. I think you understand that concept.
Yes.
Yeah. Okay. So let's move to the next technique under data transformation. Discretion or binding. You can call it discretization or binding. And what this does for us is that if you have, for instance, let me use straight. I don't want to spend more time to explain it. So let me use straight example. We have a data of 10 years from maybe 20 what? 10 years to now. 20 what is that? 2014, right?
14. Yes,
2014. So if you have a data like that, you can divide those data with, if you want to divide this with year, it will be equal like that, one year. So we can categorize those data into 10 categories like that, like one year, data of 1 year. Though we can use different methods to divide. I just use 1 year to categorize that into divide them into category based on 1 year is equal, like 1 year, 1 year, 1 year. But the criteria for division or for the category might not be it might not be year at times. It might be volume, it might be some other criteria, but they must equal. Same way, 1 year is equal 365, 365. You can neglect 366. So what I just want to bring out there that you want to divide the data into some different categories so that you can break your data. Maybe you have a very large volume of data and you want to break down them into pieces, equal pieces, so that you can be taking them, like even you can use them, maybe you analyze a particular one, you can use that judgment to you can generalize the results from one particular analysis to other one based on the fact that you categorize, as in you divide them equally, okay? And they must be a continuous data. And what I mean by continuous data, I use years as a sample, like 10 years. You start from a particular years and the data is continued like that. So it's a continuous data. Or continue, it can be data, it can be variable, it can be something, anything can be variable, but you want to categorize that continuous variable into some pieces, equal pieces, so that you can actually analyze a particular one and use it to make some decision. And this example of it, you can see this variable starts from 0 and is going to 8. So you can divide it into equal, like if you want to divide 8 into equal pieces, how many pieces are we going to have?
4.
4. So you can see here, thank you for the answer, Valentine. Plus 1, 2, 3, then that's 4. So that's just simple explanation that I think it will be easier for everybody to understand. And this is another example. We've got a database that got a large volume of data of the same variable as a continuous, like that, a continuous variable. And you just divide it into different bins. You know what we mean by bin? Like divide it to different baskets. And you have different small pieces of bin made from the same continuous variable. You can see this continuous is very important when we are talking about binding. So you can see large continuous data and you group them into small discrete bin. Okay, so is that clear to all of us?
Yes.
Thank you. Then feature engineer. Don't let me waste time. Let's just go straight. So those of us, if you know it, thank God. But if you don't know it, let me just give a brief explanation on what feature engineer is all about. You are doing a particular data. You have a data at hand. In your data, you ask people to answer how many orange do you take? And everybody say 2, 4, 5, 6, 7, 8, 9, 10. That's what they wrote for you. But what you actually need, maybe 3 decimal places. Maybe you need, if somebody have 3 orange, you want the person to input 3.007 or 3.00 or 3.0. It can be any one that you want. But people are just enter 3. And 3 is correct, right? But that's not the format that you need. So in that case, you need to carry out what we call feature engineer. So we now transform it from ordinary 3 that they input, or it could be 5, it could be any number. I'm just using those numbers for example. You now transform from that normal number they inputted, then to the format you want. If it's 3.0 that you want, you use 3.0 for, as in 0.0 for all the number, maybe 3. Let's use this same data. So like this one now, this one. So I think we're almost done, maybe in the next highest 10 minutes. So we are using extra time already. So highest 10 minutes will be through. So okay, thank you guys. So this, you can see this 1, 2, 3, 4, 5. But there might be in case in which you need 1.0, 2.0, 3.0, 4.0, 5.0. So that means you need to carry out what we know as feature engineer on this data, like transform it to that 0.0. It could be 2.0 after one that you want, maybe 1.1, 1.00 or 2.00, anyhow you want it. So that is what feature engineering is all about. And this is an example of what I'm saying, okay? I got an example here. So room number 6, but you want to transfer it to 6.0. So the process of change it to 6.0, which you need for your data analysis to work, that you want the format you want to work with, the process of transform the data to that format is what we call feature engineering. And it can happen for many data. You can see many examples here. We got 0, we got 6, 3, all of them you can see. Those ones that did not have number, this one did not have number, it is 0.0. You can see how we feature engineer this data. So some people might now be talking, okay, like this one with this number, how can I sort this one? And you can see different means of just carry out feature engineer on them and move on with what you want to do with your work. Okay, so that feature engineer, right? Okay, then we have handling date and time. All these are data transformation technique, and you can see all we are doing in all these techniques is transforming data from raw format to a more usable form. Okay, so handling date and time. If you have people to input date and time, the date and time, some people might use different format for the date and time they input, and it might, you want all your data. You can see when we are talking about the other time we are talking about these techniques. We talk about consistency. So if you have date and time with different that is not consistent, like different formats, definitely you need to correct all those things. Okay. So let me show you an example of that. So that's what handling date and time variable is in data transformation. So this example of that. Okay. So you can see we got different type of date here. We got different type of cells input here. We got different type of age input here. So you cannot analyze this type of data. So if the data is correct, but it's not in correct form. So if you analyze this data like this, it's a raw data. If you analyze it, you're going to get wrong results because you are analyzing wrong data. That's why the fact that the data is correct, you are still analyzing wrong data because you are not using the right format of data you need for your analysis. So you can see now we transform it to, you can see the new date now. There is consistency in the date, test, and year. That consistency, and you will have to be linking all these things to what we have checked under the data assessment. Okay. So that's that. As somebody message, let me see that question. What's the question? Oh, let me check. Just a minute, I just want to check the charts. I saw a message. A minute. Probably I'll check it after. Let me just round up, then we answer all the questions together. Okay, so test data transformation. So it's also possible that you have tests in your data. You need to transform it to normal number that you need for your analysis. An example of that is it. You can see acres, it can be acre, it can be hectare, and it can be anything, just like example, this is just an example. So you need to transform it to normal number. So you just, like this one, you just remove acre from it, so it will be normal number. So that is normal test data transformation. Okay, then we also have complex data type, and I think we also talked a little bit about this at the early stage of this presentation. data JSON and XML. Like if you have complex data type, maybe the data they provide for you is in JSON format. How can you make use of that? Because you cannot analyze JSON data directly. You need to transform it to a more structured data, okay, that you can use for your analysis. So this example of this. So you got this JSON format data. But before you carry out your analysis, you need to transform it to a well-structured format, which is all this table that we got here, the contact, billing, customer, and all this, they are all here. If you see, we have connection here, we have billing here, we have, so all the data are from the same purchase, which is order, and all the data you are seeing in the table, they are from this JSON data. So that's data transformation in the sense of complex data. If you have JSON data, you have to transform it into a well-structured format, okay? And also we have data integration. This is very simple to understand. If you collect, we have talked about data connection the other time, that the organization can get data from different sources, depend on the capacity of that organization. Organization have many sources of data. Now let's assume you have data from different sources. You need to now collect this data together and transfer it to like a unified data, a unified format that you can now analyze. You cannot be analyzed there individually if you are doing the analysis for the same purpose. So you need to integrate all this data together. So for this one, let's use this table. All this table, they are talking about the same customer. If you look at here, we got this ID here. You can see that we have two customers. It's just two customers, the Bob and date of birth. So majorly we have the customer, but the customer ID, the product, the customer buy, the item, the billing, which now we now have different tables. But we need to aggregate everything together to form one unified view that we can use for our analysis. So it's simply an explanation. We have different source 1, source 2, source 3. We want to integrate everything together to become a unified view that we can use for our analysis. So that's what data integration is all about. Okay, guys? And lastly, error correction. Everything we have been doing before is error correction. We are just trying to identify and correct error in our data. We have talked about data assessment, and so data assessment is more or less data error correction. So that is another transfer. So if you identify error and correct all the error in your data, that is kind of data transformation, because you have already transformed the data from bad data to a good data. And that's where we'll be stopped on the data transformation techniques. So next week, we will continue with the process involved in data wrangling and pre-processing. Okay, thank you, guys. I got an assignment for you, and it's not really an assignment, just simple work for you just to exercise your strength a little bit. So you can use any method, be it Excel, Python. You can use any tools, and you can use manual. If you want to use manual, this is the calculation. So this is the table. I got this table here. So this is the table. Let's fill this table. Let's start. Bola Amos. If I did not put your name, can you remind me your name? Valley B, that's what it's showing here. Yes. Valley B, Emmanuel. Rita. FA. Yes. If you are here and have not input your name to the table, please kindly signify. I've added Bola, Amos, Ayodeji. Okay. Ayodeji. Who else? I think we are 9. Where's Rita? Yeah, FAB, yeah. Olufemi, you did not talk. Yeah, I'll come to your question. I can see some question on the chat area. Olufemi. So I think we meet somebody did not join today, and that person is your own anyhow. Okay. So now what you will do for me is that you see this table, this example I use here, okay. So the data is already here. This is the data that you want to analyze. So for Bola, you only need answer for 64 from you, like the score, the standardization score for 64 based on this data. You just once you input your answer, let me put answer here. It's a live sheet, so if you once you input your answer, I will know that it is you. So just trace your name, or Bola, input your answer, Amos, input your answer, and what is means that you are working with the particular data in front of you. So let me just do a simple recap on that. So you calculate the mean for the entire number. You know, we have nine rows there. So you calculate the mean, then the standard deviation, then S value of it, the standardization value of it. For that particular, you can see this S means this S is your own number. S. So for Bola, this S means 64. Okay, but you are using all this number to get the mean and the standard deviation. Then once you get that, put your answer here. So I will share the link here. Let me copy the link and share it to you on the chat area. So I've sent the link, copy the link. Once you click on it, you see the same thing I'm showing to you. The formula is also down there. If you guys see the link on the chat area, please. So once you input your answer.
what we have there is YouTube link.
Oh, sorry. Oh, let me share it again.
And I was going to ask, are we going to also see the link on Discord? Because Mr. VJ opened this Discord for us the other day.
Yeah, that's good. We had it there as well. So that we have, you can see we have many means of communication. So we put it there, we'll put it on the platform, on the coaching logs. I think somebody said he did not able to find coach as well before we answer.
Yes.
So coaching, if you go to coaching, we have sent the login details to your email, like maybe after your registration, long time ago, after your registration went, we have sent you the login details. So if you go to coaching docs, so you just need to log in with your login details. Though your own login might be different from my own, you know, I'm logging as a teacher, so the interface might be a little bit different. So you might not see all the remaining costs, but you can DA, data analysis, so this data analysis. So at the moment, this is what you will see under data analysis, this seminar overview. This is the first data analysis lecture that we did then. Then this is the FJ lecture. That's this Thursday lecture. If you click on it, this lecture or lecture 0, Introduction to Data, this FJ. So if you click on it, you're able to watch the video. So the link is here. So this is the lecture. This is the link here. If you click on the link, you play. So that's the how you can get to the video on the platform. I feel, is that clear now?
Yes, thank you.
Okay, you're welcome. Then if there is any issue with the login, maybe you have login issue, you can let me know, or you can chat, you know, the Amati IT, can chat the admin, they will sort it out for you. Okay. Then let me check. I think there's some question here.
I still don't get how to get the videos, because I couldn't log into the coaching. I used the Amati email and the password given to me.
When you log in, what do you see there?
It's saying incorrect email and sign in.
And that means there is error with your login. You can chat us up tomorrow. Okay?
All right.
If you are unable to log in, there maybe you are inputting wrong password or anyhow is this, chat us up tomorrow. We correct or we help you. If you need to change your password, we help you with all those ones.
All right. Okay.
All right. So I got a question here. How do we transfer data from JSON to data structure? Yeah, you can use different tools. You can use Excel, you can use Python, you can use different tools. PJ will be taking you through all those things with Excel. The tools you will be working with, Excel, Python, a little bit of R, then SQL, SQL. So PJ will handle that, where in which we take you to Power BI, Tableau, Google Analytics, Salesforce, SPSS, and the rest. Okay, so concerning the tools, that will be, you will get there. It's just like preparation, foundation, laying the foundation for you so that it will not be like a miracle when you get it. That answer?
Okay, so I have a question. I'm trying to click on the link for the assignment you gave us now. It's taking me to OneDrive to sign in or something like that to be able to access it.
Oh, hope I did not copy it wrong. Let me do it again. But I see somebody there now. So other people are able to see it. I can see Olufemi, I can see Katos, I can see Rita. That's Efe, right? Is it Efe that is unable to access it?
Yeah, but you've done that already.
You said?
It was for the last training. You've shown that to me already.
Okay, that's good. All right, thank you. So any other question, please?
No, I'm the one. It's Bola that is asking for the link you dropped. I clicked on it and it's taking me to OneDrive to sign in or something like that.
Probably I can't really think what is going on. Maybe probably you did not have OneDrive, but it's Microsoft link. Microsoft probably did not have a app that supports that. I would think maybe I sent wrong link, but that's not the case because I can see other members there. People are already on the link already. It's a live link. So once you click on it, I will also see whatever you are doing there. So once you put your answer there, I'll be able to see it. So I'm already seeing 3 people on the page already. So that validates that the link actually working. So probably maybe you don't have the necessary app. Anyway, I don't even think you need any app, but at the same time, because online link, do any other person also have the same issue?
I think you'll need to sign into OneDrive actually.
Okay. Probably you just
OneDrive.
need to create
Yeah,
account.
just to create account and sign in.
Okay, probably you just need to create this Google Microsoft account, something like that. Yeah.
Yes, Google Drive. Yeah.
Google Drive. Yeah. Thank you for that.
Okay.
All right. Any other question, guys?
I asked
Emmanuel raised the issue with time, like, can we be starting, like, let me stop the video, all right? Let me start the recording show. Where's this? Let me stop the recording so that we can install that.